So welcome to lesson 5.1. In this lesson, we're going to add and subtract large numbers, and we're going to do that with scientific notation. So we better remember how to do scientific notation. Do these problems. 1, 2, 3, 4 moves, 3 empty spaces. That means 3 zeros and a comma in the right place. That's 52,000. Right? We can get rid of the zeros at the end. That's the whole point. Right? We always put the decimal behind the first digit, 6.04 times 10, and we're going to move the decimal 1, 2, 3, 4, 5 times 10 to the fifth. So 604,000 plus 52,000, I'm just going to stick this right under here, make my life easier. And 1, 2, 3, that's 656,000. So number 4 is what we're doing today. Well, we just showed you that that number is 604,000. And that second number is 52,000. So if that's true, then this must have the same answer, right? It must have the answer 656,000. Except we have to put our answer in scientific notation. So what would the answer be in scientific notation? Well, it'd be 6.56 times 10, and we moved it 1, 2, 3, 4, 5. And that's the answer to that. 6.56 times 10 to the fifth. If you understood all of this warm-up, you really can already do today's lesson. All right, so I'm going to give you problems like the blue one there. And you're going to convert these to regular numbers. So you'll make 4 times 10 to the third, 4,000, and 2 times 10 squared, 200. And then you add up 4,000 plus 200, just like you would have in 5th or 6th grade. And then the only extra step is then you got to convert it back to scientific notation. Okay, so we have two numbers that we're adding, and it says evaluate the expression and write in scientific notation. So we're going to start by changing them out of scientific notation. So we move that once, that's 75. All right, and the decimal point is right there behind the 2, and we move it twice because of that. And we move it twice and we get 2 empty spaces, we get 200. Hopefully we can add 200 plus 75 in our head, it's 275. But it says write the answer in scientific notation, but that is the answer. So it's 2.75 times 10, and we move this decimal twice, times 10 to the second. And there you go, that's what we're doing. Now, that is the most straightforward way to do this, and that's the way we're going to do it. You're going to notice as you do a bunch of these, there is shortcuts possible. I've tried to use the shortcuts, and too many mistakes have happened. All right, I'm going to require you to change them to regular numbers and add them that way. When we do multiplying and dividing, we will do shortcuts, but not for adding or subtracting. All right, so this is subtracting. So 1, 2, 3, 4 moves. That means 3 zeros, so that's 63,000. And then we're moving this twice, 1, 2, so that's 500, right? So I'm just going to put this 500 here, and I've intentionally, let's subtract these. We're subtracting them, not adding them. Now, I put intentionally a lot of borrowing today, because I have 8th graders who can't borrow or regroup. So let's see, right? You can't take, right, 0 minus 0 is 0, 0 minus 0 is 0, but you can't take 5 from 0, right? You have to borrow from there, make it a 2, and regroup it, and get 10 minus 5 is 5. Then this comes down, and the answer is 62,500. But the instructions say you got to put it back in scientific notation. So it's 6.25 times 1, 2, 3, 4 times 10 to the fourth. All right. So some of them are adding, some of them are subtracting, but you do them the same way. Okay. Scientists found 2 asteroids with masses of 4.06 times 10 to the 8th and 2 times 10 to the 7th kilograms. Find the total mass. So what do we do for total? We add, right? So we're adding 4.06 times 10 to the 8th, and we're going to add that to 2 times 10 to the 7th. All right, so let's do the top one. We're going to move it 8 times. We're going to get 6 zeros there, right? 1, 2, 3, 4, 5, 6. So that's 406 million, right? The bottom one, the decimal point is right there. We're going to move it 7 times. We're going to get 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then the 2. And we're subtracting those. And neatness is going to count, right? Because you got to line everything up. So that's a 0, that's a 0, that's a 0, comma, 0, 0, 0, comma, 6 minus 0, 6. Now you can't take 2 from 0, right? You're borrowing, right? And that's 386 million. But it says write your answer in scientific notation. So it's 3.86 times 10, and we've moved that. Right now you can use these commas, right? It's 3 to each comma. 3, then 6, then 2 more to get there. So it's 3.686 times 10 to the 8th. It's a word problem, so put a word on it. Kilograms. So to find a total, or you go to the grocery store, they total your groceries, they add them up. All right, so now we have 2 elephants. We're finding the difference in their weights. So what's different? All right, well, now we're going to be subtracting. So we got to put the bigger one, the one with 10 to the 4th, right? You just look at the exponent. The bigger one's going to be up top, right, to do the subtraction. And so we're going to change both of these to regular numbers. Move this 4 times. 1, 2, 3, 4. So we have 2 zeros. So that's 13,600. And we're going to subtract, move this, right, the decimals behind the 9 right there. Move it 3 times, 3 zeros in this case. So one of these elephants weighs 13,600 pounds, the other 9,000 pounds. We subtract the 2, and we get 4,600. To make that into scientific notation, 4.6 times 10, 1, 2, 3, times 10 to the 3rd, and these were LBS pounds. All right, try this one. So 4.5 times 10 to the 4th. 1, 2, 3, 4. Okay. So we're going to move it 3 times. We're moving it 4 times. We're adding 3 zeros. I apologize. We're adding. And then this one we're moving 4 times. 1, 2, 3, 4. And so this has 4 zeros. Whoops, I'm going to put the commas have to be in the same spot, don't they? So that's 20,000. And we add those together and we get 65,000. And 65,000 is 6.5 times 10 to the 4th, right? 1, 2, 3, 4. Try this one. We're subtracting here. So 1, 2, 3, 4, 5. There's going to be 4 zeros there. And we're going to subtract from 730,000. We're going to move this 5 times. 1, 2, 3, 4, 5. We're going to add 4 zeros there. 1, 2, 3, 4. And that, we're subtracting this time, right? And we have 220,000. 220,000 is 2.2 times 10 to the 5th. All right, now, when the two numbers have the exact same exponent as each other, there is a shortcut available. Not, right, the other ones, any shortcuts lead to mistakes. But when they have the exact same exponent, you can take a shortcut. And why is that? Well, because if you have, say, 4.5 x to the 4th plus 2 times, and this is, let's use y because we're using x for times in these, 4.5 y to the 4th plus 2y to the 4th. This is like this problem, right? What would that be? That would be 6.5 times y to the 4th. Compare that, right? Because now these are like terms. When the exponents are the same, they're like terms, and you can just add 4.5 plus 2, right? 2 plus 4 is 6, so it's 4.5 is 6.5. Now, if you think that you're someone who might do 4.5 plus 2 and get 4.7, if you're that person, don't do this shortcut ever. All right, do it the way you do all the other ones. But when the exponents are the same, if you want to take this shortcut, you may do it that way. So let's see it here, right? The exponents are the same, right? So if you had, say, 7.3 y to the 5th plus minus, this is minus 5.1 y to the 5th, right? That would be 2.2 y to the 5th. And so all you need to do was do 7.3 minus 5.1 and then keep the 5, all right? So you understand, hopefully, when you can use a shortcut and when you can't. When the exponents are the same as each other, that's the only time for shortcuts in this class. Okay, scientists found 2 asteroids with masses of 5.3 times 10 to the 8th and 4 times 10 to the 8th, all right? So they have the same exponent. So I'm going to do it both ways. I'll do the shortcut first. All right, so the shortcut, right? They have the same exponent, so I can just add 5.3 plus 4, and I get 9.3. And since it's times 10 to the 8th, it's times 10 to the 8th kilograms. All right. Now, regular way. All right, the regular way is 5.3 times 10 to the 8th. I have to move it 8 times. I'm going to get 7 zeros. So 1, 2, 3, 4, 5, 6, 7. And there are our commas. That's 530 million. 4 times 10 to the 8th. 8 times I'm going to get 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. I'm subtracting them. Oh no, I'm adding them, right? Oh no, oh my goodness. So I find the difference. Some of you have been screaming at the screen, Mr. Ben, you messed up, hopefully, right? Because it's difference. Don't do that. It's 1.3 kilograms. So I'm subtracting. And so you get 130 million, which is 1.3 times 10 to the 8th kilograms. All right. So, I'm even nice that I underline difference in these problems so you'll know which ones are subtraction, and Mr. Ben still missed it. Don't you be that way. All right, so the shortcut when it's there is nice. Okay, practice. So the exponents are all different. We're doing it the regular way, right? So this one is move it 5 times, get 4 zeros, 840,000. Move it 3 times, get 2 zeros, 1, 2. All right, so we're 840,000 minus 7,100. All right, so we're going to have some borrowing here, and that's intentional. So let's see. Can't take 1 from 0, can't borrow from 0. The 4 becomes a 3, that becomes a 10, cross it out, becomes a 9, that becomes a 10, that becomes a 9, 2, 3, 8. So it's 832,900, which is 8.329 times 10 to the 1, 2, 3, 4, 5, times 10 to the 5th. This one we're adding, moving it twice, that's 916, right? No zeros added. Moving it 6 times, you're going to get 5 zeros. I'm going to put this one on the bottom just. All right, so you get 5 0. 1, 2, 3, 4, 5 zeros, and then the 2, 5. And we're adding these up. Wow, this is pretty easy. All right, so 0, 0, 5, 2. All I have to do is make sure I line things up right. So this is a problem with scientific notation here, right? With this whole method, right? This answer is 2,500,916. Well, you try to put that number in scientific notation, and look what happens. It's horrible, right? It doesn't save you anything. And let's see, 1, 2, 3, 4, 5, 6. Yeah, times 10 to the 6th. Right, so that's a good example where scientific notation, which is solely, designed so we don't write lots and lots of zeros when we're dealing with millions, billions, and quadrillions and such. There, because of this 916, we wouldn't really use it in real life. Right, so the exponents are the same, so this avails you with this. But now you have to make sure you do this. So there's the shortcut, and you're going to borrow, and you get 1.6 times 10 to the 5th. You keep the exponent. The regular way, move it 5 times, you're going to get 5 zeros here. 3, 4, 5, that's 900,000. Move that 5 times, you're going to get 4 zeros. And you get that. And you get this, comma, borrowing, you get the 6, you get the 1, you get 16,000, and whoops, I missed a 0 there. Because I was like, this is not the same answer. There you go, you get 160,000. And so then it's 1.6 times 10, 1, 2, 3, 4, 5, times 10 to the 5th. Find the total weight. All right, different exponents. 1.06 times 10 to the 4th is, move it 4 times, add 2 zeros, 10,600. 7.5 times 10 cubed, move it 3 times, get 2 zeros. And we're finding a total, so we're adding that together. And I'm getting 18,100. So it's 1.81 times 10 to the 1, 2, 3, 4. And make sure, I'm worried that I forgot units on one of the word problems, but you're putting words on all your word problems. Good luck on the homework.